Okay, so today we're starting the second objective of our Unit 5, 5.2a, the topic solving exponential equations. This is just the basic lesson for solving an exponential equation. Today, all the equations you write, you will be able to write them with the same base. So we won't have to use a calculator to solve any. All right, so your objective, you will be successful when you can identify the common base. That's the biggest part. Rewrite the equation by substituting with the common base, apply the power rule, and 3, to solve the resulting equation. So before we can do that, let's start with some vocabulary. Okay, first we have what is an exponential equation, different than an exponential function. We've been working on exponential functions. Just to remind you, an exponential function is where we have f of x is equal to 4 to the x power. The x and the exponent makes it an exponential function, but it has two variables, an x and a y. So that's what we worked on, and we graphed them. Today we're just solving an exponential equation. An exponential equation is an equation with a variable and the exponent. Looks like this. 4 to the x power equals 16. An exponential equation where x is in the exponent, or b, or whatever variable we choose, but it's in one variable, not two, not x, y. We will not be graphing. That's not my water. Okay? There is a rule that says if we can write the exponents, or both sides of the equation, in the same base, if the base to the m power is equal to the same base to the m power, then I can say that their exponents are equivalent. For example, let's say I have 3 to the x equals 3 to the 4th. They are the same base, correct? Therefore, I can set the exponents, x is equal to 4. If their bases are the same, then their exponents will be equivalent. This is just a visual to represent this general rule. And then if we can't do this, then we have to go to our calculator and do other things to find the answer. Okay, we will be using these rules. The product rule. Remember that the product rule says, come on, if I'm multiplying two bases that are the same, I add their exponents. We know this, and matter of factly, we will not be using this power rule or this exponent rule today. We will use it tomorrow. But we know this, like if I say x cubed times x squared, you tell me it's x to the 5th. You add the exponents. We know this. Okay, we will be using, however, today, the power rule. It says if we have a base raised to a power and we raise that whole thing to another power, we multiply the powers. We will be using this a lot today. It is step 2 of our process. Also, we will be applying the negative exponent rule. Let's talk about the basic negative exponent rule. It says if I have some base raised to a negative exponent, if I want to evaluate that, I would write it as 1 over the base to the positive exponent. We know this. But we're not going to use this version of the rule. We are going to use this version that says if I have some number 1 over some base raised to the m, we have to raise that base out of the denominator today. And we're going to write it as b raised to the negative m. So we will be using this one often today. We're solving equations. So when you're solving equations, you always work in reverse. So we'll be using the reverse of this rule. So those are these two that I've circled, these are the ones we're going to use today. All right, so here are the steps. If we're going to solve an exponential equation, we need to make sure to convert all of the terms to the greatest common base. We want them to be the same base so that we can solve the equation. And when we're done with that, switching colors to green, you're going to apply the power rule. Once we apply the power rule, we will be able to set the exponents equal to each other and solve for the variable. And then we'll check the solution, and you can check it with your calculator, or you can check it by hand. That's up to you. All right, so what I did here was I just provided a little table. We're going to fill it out. So we'll have the base 2's all the way to the base 9's, and I overdid it. I gave more powers of 2 and 3 and all of that than is necessary, but still, we're going to fill it out. So base 2, so here's the bases, and then here's the quantities squared, cubed, to the 4th power, etc. Let's do the 2's. So 2 to the 4th, 16. 2 to the 5th is 32. Keep up. 2 to the 6th is 64. 128. And 256. So those are your powers of 2. Probably we would be good to know all of them. So they're all there. Right, let's do the powers of 3. So 3 cubed. 3 to the 4th is 81. 3 to the 5th is 243. Then 3 to the 6th is 729. Powers of 4. 4 squared is 16. 64. 256. 512. Powers of 5. 5 squared is 25. Then 125. Then 625. Then 31. 25. All the powers of 5 end in 25. Let's do the 6's. 6 squared is 36. 6 cubed is 216. You'll see 216 a couple times in your homework. And then let's see what's next. Oh, 1296. 1296. Question. 4 to the 5th is 512. No, 4 to the 5th is 1024. Thank you. It's 1024. Thank you, Tyler. I just doubled it. Yeah. Not cool, frame, not cool. Okay, sorry. Change that. Ooh, I was going to put that up in the interwebs, and it was going to be wrong. Okay, let's do the 7th power. It's the powers of 7, base 7. 7 squared is 49. 7 cubed is 343. And 7 to the 4th power is 2401. Powers of 8. 8 squared is 64. Here it is 512. And 4096. And then the 9's. 9 squared is 81. 9 cubed is 729. Have them handy when you're doing your homework. Okay. So if I were like to tell you just real quickly so we know how to use this table carefully, if I were to say 27 to the x equals 81 to the 4th, what base will I see both of them in? 3. Base 3? Look, there's 27 and there's 81. So I could replace 27 with a base 3. 3 to the what power? Cubed. And 81 would be 3 to the 4th. So now that's what I mean. So you're going to use that table and you're going to look for those, the base. And you'll see the numbers in the bases row. Okay? All right, here we go. So let's do some practice. And I'm color coding, so I'm going to my purple pen. Step 1. The first thing I have to do, step 1, is identify the common base. So I'm looking at my two bases, 3 and 9. And of course, I'm going to the greatest common base, and I can't go larger than the smaller base. Can I make 9 base 3? Of course. So I'm going to rewrite it. So 9 I'll replace with a base 3 to the what power? 3 squared to the 4th. So I'm just substituting in 3 squared for 9 so that my bases are the same. Now I'm switching to my second step, which is to apply the power rule. Right? That happens right here. Correct? So I have 3 to the x equals 3 to the 8th. So that's step 2, apply the power rule. And now what you'll notice is that the bases are the same. Since the bases are the same, that means the exponents are equivalent. And I don't have anything to solve here. It's solved for me. So in solution set, x is 8. And I'll do a little check here where I say 3 to the 8th equals 9 to the 4th. You can plug that into your calculator. They'll both be fairly large numbers, but you can see that it's actually true by plugging it into your calculator. I don't have my calculator opened up. Somebody have one? Out? Don't get them out if you don't have them. It's not a big deal. Nick's got it. Go, Nick. What's 3 to the 8th?
6,561.
And 9 to the 4th?
6,561.
Check. We got it right. Okay? Doesn't hurt to check to make sure you've done it right. So there we go. First one done. Let's practice again. So you know what I forgot to do up here? I forgot to write down my first step, which was my common base. Identify base 3. So I'm going to write that down. Okay, I'm going back to step 1, and I'm going to identify the common base. So I look at my two bases, 4 and 16, and I look to the smaller one and I ask myself, can I make the larger base into a base 4? Yes. So I could also make them both base 2, but that's going to require extra work on my part. It won't make my answer wrong, just makes more work. So we'll rewrite so that they are both base 4. So 16 I would replace with 4 to the 2nd cubed. Now I'm switching colors, and I'm going to apply my power rule. So I get 4 to the negative 2x equals 4 to the 6th power. And now that my bases are the same, if my bases are the same, then the exponents are equivalent. And hey, that's a basic old solve the equation. Divide by negative 2 to isolate the x. X equals negative 3. Oh, I didn't mean to put a brace on that. And then we'll put our answer in solution set. And of course, we can check it. 4 to the negative 2 times negative 3 is equal to 16 cubed. This one's pretty similar to the last one. 4 to the 6th equals 16 cubed. It's a lot like 3 to the 8th equals 9 to the 4th. Nick, you got it? Go.
4 to the 6th is 4,096.
And 16 cubed?
4,096.
Got it. Beautiful. It's perfect. Check. All right. Here we go. Now we're going to have to think a little bit about what's happening in this problem. I have 1/5 and 1/25. And I want to make them both the same base. But this one's going to end up being a negative exponent, right? Need to change it to a whole number. What is the common base here? I see a 5. Okay, so how would I turn this into a base 5? It's 1/5. Reciprocal and change it from a positive 1 to a negative 1. 5 to the negative 1 is the same as 1/5 to the negative 2 is equal to, and 125 is base 5 cubed to the 2x. There you go. Beautiful. All right. And I think now we can apply our power rule. So I'm switching colors and I'm going to multiply. And I get 5 squared equals 5 to the 6x. Looks good to me. So since my bases are the same, then my exponents are equivalent. 2 equals 6x. Divide by 6. Simplify. X equals 1/3. Okay. Time for the check. So Nick, plug in 1/5 to the negative 2. Not that you couldn't do that in your head. You got it, 25. Now plug in 1/25 to the 2/3. I multiplied it out for you, to the 2/3 power. Can you plug it in? It's 25. Just got to raise it to the fraction. It is 25. Yep. Look at that. Genius. I love it. Okay. Now a little bit more complicated, but only slightly. And of course we can handle it. So here we have 2 powers. And this is where I'm going to start separating the people that are paying attention, the people that just think they get it. Okay. Here I have a base 4 and a base 32. So I look to the base 4 and I look to that row of base 4s. Is 32 in that row? No. So then I have to go smaller than base 4. And the next one down is 2, right? Because it's certainly not base 3. 32 in base 2? Yes. So this time their common base is 2. And I should be doing this in purple. And here's where I start getting the question, yeah, but Mrs. Frame, 4 times 8 is 32. That's true. But 4 to what power is 32? It's 4 to some fraction power. We're not doing that. Okay? So we're going to rewrite them base 2. So 4 will replace with 2 squared. And pay attention. This exponent is a binomial, so you know what you got to do? Put parentheses around it. You're going to have to distribute. And let's replace 32 with 2 to the 5th to the 4th. So replacing 32 with 2 to the 5th. Okay, power rule. So we're going to distribute. So that'll be 2 to the 2x plus 4 equals distribute 2 to the 20th. And now they're same base. So we can take their exponents. Bases are the same, then exponents are equivalent. And we can solve that very simple 2-step equation for x by subtracting 4. 2x equals 16. Divide by not 2. Yes, 2. I wrote 8. I meant 2. X equals 8. Solution set 8. And we're not going to check anymore because we are running low on time. We got 2 left to do and 2 minutes left to do it. Okay, this next one is a special circumstance where our answer will be all reals. Okay, so let's look for our common base. Here I have a base 6, and over here I have 1 over 216. Is 216 in my base 6 column? Or row? Yeah, it is. So that's base 6. So we're going to have 2 to the 3x equals 1 over 6 to the what? Cubed? Yeah, cubed. So that's 1 over 6 cubed to the negative x. And then we have to make them both base 6. So how am I going to bring that up? Change this to a negative 3 to the negative x. Apply the power rule quickly. So that's 6 to the 3x equals 6 to the 3x. They're equivalent, right? So 3x equals, oh, wrong color. 3x equals 3x. Subtract 3x from both sides. We get 0 equals 0. No x. True statement. Therefore, I can pick any number I want. Real or irrational, irrational, doesn't matter. Okay, guys, we got to go fast. Last one. This one is the empty set. Quickly, we'll go fast. Okay, what's the common base? Base 2. All right, so can we write 8 as base 2, 1/8 as base 2 as 2 to the negative 3? Quickly, x minus 2 and 2 to the 3 minus 3x. Quickly, guys, we're going to get it done. I'm sorry. Distribute. Power rule. That's 2 to the negative 3x plus 6 equals 2 to the 3x minus 3. We're going. Come on. Negative 3x plus 6 equals 3 minus 3x. Add 3x. They cancel out, and you're left with the statement 6 equals 3. This is false. Therefore, oh, empty set. No number inside. Empty set. Your homework. Problems 1 through 20.